Okay, so section 5.7, if you want to follow in the book, it's on page 278. However, you would be much better served by following what's going on up here on the board. And what is CPCTC to you? Do you recall? Everybody remember what it stands for? You better remember what it stands for. See? Congruent triangles? Congruent triangles are congruent. So if you're watching this video and hoping to get a lecture on CPCTC, you might want to backtrack to section 5.4 and look at the very end of the tape, because we talked about it yesterday. I'm not going to do it entirely again. But CPCTC, this is where the imply sign would go. All of this over here has to happen before the congruent part of the parts can. And the thing that throws this off a little bit is the fact that people don't understand their own English language very well. Corresponding parts, that's the subject of the sentence. Then there's a prepositional phrase, corresponding parts of congruent triangles. I haven't even hit the verb yet, which means all of this stuff is given or has to be established before it can mean or imply congruent. In other words, the word are goes right here. That's your verb, and all of this has to happen first. This part, you identify. You see this in the picture. You have to be able to say, yep, those are corresponding. You have to identify that. So you see this in the picture. This is the killer. This has to be done first. Must have congruent triangles, or this doesn't apply. Most of your proof will be going to establish this, the congruent triangles. Once you have congruent triangles, then any of their other corresponding parts will be equal. The subject, the corresponding parts will be equal if you get the congruent triangles. You follow me? This CPCTC should never come before congruent triangles have been established. So don't just throw it down because you don't know what else to do. It always follows on the heels of congruent triangles, and not always on the very next step, but it must always come after you have two triangles congruent. So I'm going to erase this now. We're going to do this proof here, and I'll show you how it fits into a proof. Okay, so in this proof right here, it tells us that angle 1, that's this big monster here, and angle 2, that's this big old obtuse thing here, those are equal. So we got those equal. And they give us that 3 and 4 are equal. I guess we better put different marks on those. They're certainly not the same size. And I didn't draw this very well, but there is actually a corner here. It's just a super, super obtuse angle, but it's not a straight line. Y'all see that? It's bent a little bit. Okay. All right. So that's all you get. We've got it marked. And we're trying to prove that QT, which is right here, this side from Q to T, is as long as T to S. Now, my question to you is, do you believe or do you recognize that QT and ST are corresponding parts of those two triangles? Okay. Then the objective should be to prove the triangles are equal, because then the parts will follow suit. Okay. And all we have so far inside these triangles is a single angle pair. We need, well, you can't use side-side angles, so we don't need two other sides. We need another side and another angle pair that we can get in some pattern or another. Yes.
Couldn't you say angle QT, RQT, and RST?
Let's call these 5 and 6.
Couldn't you say that those are equal?
Nope, not yet, but that's what we're going to go after.
So you would say 2 and 6 are linear pair and 1 and 5 are linear pair?
I would say that 1 and 5 add up to 180. So I can get right to an equation rather than say they're a linear pair. But yes, that's the route you got to go. Yes.
RT is equal to RT because of reflexive.
Yep, she saw the reflexive. So that can be mentioned anywhere before the congruent triangles are stated. So if you all see that, then maybe we ought to mention that first, and then we'll focus on what you want to do. Okay, is that all right? Okay, we'll get the easy part first. So in number 2, we can say RT equals RT because they both have that as a side. Oops. Step 2, reflexive. And we'll mark. So based on what Andrew's trying to tell us here, it looks like we're shooting for an angle side, which is legal. That's a good one, right? Angle side's good. The reason why we're shooting for that is because the only other information we have, which is angle 1 and angle 2, seem to be tied to 5 and 6, which are inside the triangles. So that tells you which angles you want to go after. And what you said before is, yes, 2 and 6 are a linear pair. That doesn't give us an equation. If we went 2 plus 6 equals 180, we have a reason for that. It's a see it, say it thing. If you got a reason for that, then it's easier, it's better if you can get an equation put into the proof early on. So step 3, that's just what we're going to do. We're going to say angle 2 plus angle 6 equals 180. And we're going to do the very same thing for the other one. Angle 1 plus angle 5 equals 180. And they're both for the same reason, which is 180 in a straight angle, because that's something you can see it, you can say it. Okay. Now we have not said that 5 equals 6. That's what we're shooting for. But we got two things equal to 180. So substitution, if you've done enough of these proofs, that should be a fairly obvious follow through on this. Angle 2 plus angle 6 equals angle 1 plus angle 5 because of substitution. Can you all see that? You got two things, this thingy here and this thingy here, and they're both equal to 180. So those thingies are equal to each other. That's substitution. That's the heart and soul of it, if you can recognize it. Which is close to what I need. I'm trying to get 5 equals 6 to finish this off, and I got a 6 here and a 5 here. If I could just get rid of these two. Oh, but I can, because they're equal, and it says so. So I can subtract those without doing a substitution or anything in here and saying angle 1 equals angle 1 plus 6 equals 1 plus 5. The fact that they are stated that they are equal up here, they are the same thing. 1 and 2 are the same, so I can drop them with subtraction. So I would say angle 6 equals angle 5 by subtraction. You can't use this unless you're sure that 1 equals 2 someplace, and we are. So now I've got the last ones. And now that I've actually said that they are equal, I count up my parts that are equal. I've got 1 and 2 handed me this. So that's not a thing I can count. But I've got this angle pair, that's 1. I got this side pair, that's 2. And I finally got this angle pair in the triangles, that's 3. So I've got enough now to say that triangle. And now's where your naming skills have to come in. Because before, they've already named it for you. But when you're trying to prove triangles were congruent, they already named them for you in order. You have to think about it. Now you have to think about it because you got to write your own congruent statement that's true. So if I say QRT for one of my triangles, and by the way, the first one is arbitrary. You can name it however you want. But you have to name the other one the same way. What would it be? Pardon?
SRT.
SRT. And it has to be in that order or you'll miss this step. I'm looking for it. So don't just lay it down any old way you want. And that's because of angle, side. That pattern is built in the picture. Then you got to go another step. And that is to say that QT equals ST. We've already decided their corresponding parts. Now we can say of congruent triangles, as we spent all the proof getting to. So these are corresponding parts that we recognize. They belong together. Of congruent triangles, which came in this step just before it, are congruent. There's your congruent right there. The end thing. We decided they're equal because of that. Corresponding parts of congruent triangles are congruent. See how we're going to use it? It's not beyond your reach. It's just that they didn't hand us 5 and 6, and it took a few steps to get it. See it? Everybody good? Okay. This one over here is going to be a little tougher. So we don't get any glare. So if you're watching this, you might want to look away a minute. You're going to get dizzy. Back in. I think my computer lasts about as long as that proof did. I gotta plug it in now. I'm gonna lose it. Stupid things. You guys want to make a lot of money. Improve batteries and all this crap. Yeah. All right. So the second proof, if you want to follow, I don't know that you want to. He does his solution with a paragraph proof, which I haven't taught you to read yet. So we're just going to do it from scratch over here. Here's our situation here. We've got, they tell us right in the given that angle 1 equals angle 2. So I'm going to mark it. Because when it actually says they're equal, you should mark it so you can see where you're headed. 3 equals 4. And that's it. That's all you get. And look, we're trying to prove two triangles are equal. Feels like we're going backwards from what we did over here. Over here, we wanted to prove two parts were equal. But here we want to prove two triangles are equal. Let's look at where the triangles are. Because you're going to be surprised at what we're going to have to do here to get this done. It's triangle CDE. So I'm gonna mark it in blue so we can keep in mind where we're headed. CDE is this guy, and the other one is this one. So it's those two blue ones right there. And I think some of you can see an obvious thing that we could say right now about those two blue ones. CE equals CE. Okay, so we mark that, and we're well on our way. Except there's nothing else there. There's nothing else in the given. There's nothing that we can see and say for those two triangles, and we still only have two parts. We've got an angle side. And that's it.
Could you say like angle E equals angle E?
No, because there's four of them there.
Could you say CA equals CA?
We-
Figure out. And then
yeah.
you know what the whole triangle is.
Oh, so you want to go after some big ones. It's a good idea. Let me tell you why this is something that may not have occurred to you. You've never seen anything like this before. And I think it's starting to occur to Andrew and maybe some of the rest of you that are pretty good at proofs. What we're going to do, and it's the word that I use, I hope you understand what I mean. But what we're going to do is we're going to prove two triangles are equal that we can prove are equal. Then we're going to cannibalize their parts using CPCTC. In other words, folks, we're going to get a couple of triangles equal that is possible to do, and Andrew's shooting for that. I can see it right now, but we're going to get a couple of triangles in this picture equal that we can get equal, and then any parts that those triangles have, that these blue triangles also have, we can CPCTC them. So this one's even more convoluted than that thing over there. There was only two triangles over there. There's a whole bunch of triangles here. There's 1, 2, 3, 4, 5, 6 at least triangles. And these big guys, I think Andrew sees it, these big ones right here with the 3 and the 4 in it and the 2. We got a 4 and a 2 in this one. We got a 1 and a 3 in this one. These big guys right here, we can show that they are equal really fast. Because all we got to do is get a reflexive CA as he suggested. You see it? Then if I big guy is equal to this big guy, then I can borrow these two parts right here, the CD and the CB, because they belong to the big ones. They also belong to my blue ones. That's what I mean by cannibalizing the parts of the ones we can prove to add what we need to get the ones we can't. We cannot prove these are equal directly. We got to get what we can and use their parts that they share to get the remaining pieces. So my new goal, which is a subroutine here, is to prove that this big long guy right here and this big guy right here are equal, and it's not very hard. I could, as a matter of fact, once I see it, right here in this step, write CA equals CA, because it's reflexive too, the big one. It's kind of hard to mark because there's so much going on here. But here's what's going on. I got this triangle and I've got this triangle. If I separate them, I've just said that this equals this. Okay, I have this, and this, and this, and this. And so those triangles are equal angle side angle right now. See it? Or not? Yeah? Okay, so I'm going to name those triangles. Triangle CDA is equal to triangle what? Sorry? CBA, and it has to be in that order. And that would be angle side angle. Now I'm focused back on my blue ones because I can borrow parts from this that I need. And I'm going to borrow the part CD and CB. Because those guys, that's these guys right here. Those are parts. Those are parts that that weren't part of proving these were equal, but they are corresponding parts now. So I can get that equals that, which also belongs to the blue triangle. So from the big ones, I get a CPCTC. And then that means in the big picture up here, I've got this is equal to this, and I've got now side angle side on the blue ones I was after. You see? Okay. So sometimes you got to borrow parts from ones you can prove to get to the ones you want to prove. So triangle, it's up there now. I can just copy it. CDE is equal to triangle BCD. Now that I've established it is side angle side. So just to review here real quick, I had an angle pair, 1 and 2, in my blue triangles. I also got the reflexive, that most of you seem to recognize, that's my side, and then it all fell apart on me. I got my remaining side from this congruent set of the big ones. So I got my remaining side there, and then the pattern was side angle side for the triangle as I was really after. So this will give you some idea of the types of thoughts and things that you've got to have to do these. Really, demonstrating more isn't going to get you where you want to be. You got to do this. You got to actually experience it and do it, and look at different situations and see if you can follow through and learn to get good at this. So I have a worksheet for you, and the assignment is not out of the book. The assignment is this, and it's got 10 proofs and a little thing on the back where you got to fill in the blanks. I need you to know what CPCTC stands for. They're all set to go. All the givens are there. The pictures are drawn, so you should just be able to get right to the thinking without having to take so much time to draw it out. Okay? If you are really good at this and you have to get done today, then bring something to class to do tomorrow. Well, I can give you something to do. I can give you all the review assignments today. I'll write it on the board, and then if you get done with this, you can get started on that. Okay? All right. That's all there is for this thing, just those two examples. So yeah.